49, we're asked to factor x squared minus 121. This form is called a difference of two squares. When you have two terms and a subtraction in between, and both are perfect squares, it factors like this. X squared is x times x. The square root of 121 is 11. It's 11 times 11. 1 parentheses gets a plus, 1 gets a minus. Again, if we use this FOIL multiplication, first x times x gives x squared. Last, 11 times 11 is this 121. The outside and the inside will cancel because of positive 11x and negative 11x, they would sum to 0. There's your answer. All right, 52. Solve this equation, z squared minus 81. First of all, we could solve this like this previous one where we solved by factoring, but this one will also solve directly. Since there's no linear term here, we can add 81 to both sides. We get z squared is equal to 81, and we can take the square root of both sides. This gives us z is equal to both positive and negative 9. From here to here, we took the square root of both sides. But this also can be solved like the previous one. It looks to me like this exercise is a factoring exercise, so I'm showing this second separate way. Factoring z squared minus 81, like in 49, this becomes z plus 9 is z minus 9. When we have two factors that are multiplied to give 0, one of them must be 0. We set them individually equal to 0. Z plus 9 is 0, or z minus 9 is 0. Here, subtracting 9 from both sides, we get z is a negative 9. Here, adding 9 to both sides, we get z is a positive 9. And these two answers, they're the same. To say this, z is plus or minus 9, is the same as saying both of these things over here. I didn't realize it, but my red and green ink's kind of Christmassy, isn't it? Okay, these next several are asking to graph functions and compare them to the function f of x equal x squared. Well, 50, what is that? 56? 56. So each one of these, we're going to start by graphing what's called the parent quadratic function, f of x equals x squared. Well, this thing is this parabola here, this upward shaped, this U-shaped curve called a parabola. All right. A couple of key points: 0 pairs with 0. 1 pairs with 1. And negative 1 pairs with 1, pardon me. She's probably familiar with that. Well, we're also asked to graph a second function, h of x is equal to 4x squared. Well, how this thing is going to compare is it's going to be what's called a vertical stretch. It's skinnier. All right, the fact this 4 here causes this thing to be narrower than the previous one. The math term here is a vertical stretch. Right. $59. So we got to start with our same parent function. We're graphing the same original one, f of x equal x squared. It's this upward, it's this parabola here. And then the second one we're asked to graph here, called a of x. And this f and a, that's just the names of them, totally arbitrary. It could be anything. Negative 7x squared. Well, it's going to be similar. First, this negative causes it to open down. Okay. And this 7 is again a stretch. So it's going to be even skinnier than this previous one. It's going to be really skinny, and it's going to open down. it's a reflection, that's that flipping, and a vertical stretch. It's the skinnier. The bigger this number, the bigger this coefficient here, the skinnier the parabola. If this thing is negative, it opens down instead of up. All right. $62. Again, we have our parent function, f of x equal x squared. It's this parabola. And we're going to transform it, the new one called g of x is equal to x squared plus 3. Well, this number here causes it to translate, slide. This is a vertical translation. By translation, we mean to slide. It moves it. It's not going to make it skinnier. It's just going to slide it up. So this new graph will, this 3 will cause this thing to shift up 3 units. So where that one's at 0, 0, this one will be at 0, 3. Same shape, just been slid up 3 units. It may look skinnier. They're really the same width. Exactly the same shape. It's just been slid up 3 units. Okay, last one of this group, 65. Again, our original function, f of x is equal to x squared. Got this upward opening parabola. And then we're graphing our parent, our transformation. They say s of x is equal to negative x squared minus 2. Alright, this 2 is again a vertical translation. It's going to slide it. Vertical translation. Down 2 because of the minus. And this negative is going to make a reflection. It flips it. Reflect means flip. So this thing is going to open downward and be slid down 2 units. So here it's going to have the vertex at 0, negative 2. It's going to open down. It's exactly the same shape as the other one, just opening in the downward direction. All right. So generally here, in this form that we've seen, I'm going to call this y equals ax squared plus c. This thing here affects the width, how skinny it is, and the direction of opening. If it's negative, it opens down. And this c will slide it, translate, slide it up or down. This, all right.